All right, chemistry kids, here's the last installment of the videos for our matter and energy unit. And here's we're talking about the big ideas here. Big ideas, in other words, things you should be putting together and how things kind of work. All right, so here we go. Here's 3 questions. I'll probably add a little bit more. Hopefully this talk doesn't take too long. We'll see. What's the law of conservation? How does it apply? Well, law of conservation means that everything is conserved. So when you start with to what you end with. So basically, you could say law of conservation of mass. You could say law of conservation of energy. Okay, so what the law of conservation means that mass is conserved throughout, say, a chemical reaction. That energy is conserved throughout a reaction. Okay, all the stuff should be conserved inside a closed system. Keyword, closed system. No outside forces. All right. So when you weigh something and a reaction happens, if there's no outside forces, it should weigh the same when it's done. All right. Energy should be the same, okay, but it's not always because there's external forces. All right. So when you're changing states, all right, for example, if I'm going from a solid to a liquid, say if I'm melting ice, all right, I melt ice. So if I start with 20 grams of ice to start with, and I melt it nice and slow and not heat up too fast, if I start with 20 grams of ice, I should end with 20 grams of liquid. Should, okay, but that's in a perfect world, ideal world, but not always going to happen, okay, because there's outside forces. You might lose some to evaporation, stirring inside of a container. There's lots of things that could go wrong. All right, so as long as the numbers are close, you should be fine. What about a chemical reaction? Well, first of all, remember, how do you know a chemical reaction took place? Look at the 4 signs of the chemical reaction. All right, bubbles given off, color change, precipitate gets formed, energy change. Even when a chemical reaction takes place, mass and everything should be conserved. All right, here's my example. Let's say I have an atom. And let's say I have atom X. Say I have atom Y and atom X. All right, so here's atom Y, here's atom X. Let's say I want to chemically combine those two. So I put them through a reaction. All right, and let's say I have 1, 2, 3. Let's say I have 3 molecules of Y and I have 4 molecules of X. I put them through a reaction. And when these combine, they usually only combine in certain ratios. All right. So let's say that every X we have combines with 1 Y. All right. So when I combine them, they're going to look something like this. There's that. Okay. There's a molecule, new properties, everything like that. All right. Let's say, and then we had made another one. All right. And then let's say we made another one. Here's the trick, though. You can't make any more. Why? Because I only started with 3 molecules of Y, and they only combine in a 1-to-1 ratio. That means I have an extra X floating around, not reacting with anything. Mass is conserved. The amount of atoms are conserved. The energy is conserved. Everything is conserved. So you got to think in pictures. If I have a certain number of atoms to start with, I should end up with those certain number of atoms, as long as we know how to combine them. So here I have 3 molecules. And notice I have 1, 2, 3 molecules here, and I have 1, 2, 3 molecules here, but I have the 1 extra left over, and that's the one that didn't react with anything because there wasn't anything to react with. All right. So chemical reactions do apply to the law of conservation because mass should be conserved. What you start with, you should end with. If you end with 10 grams, you should end with 10 grams. If you start with 5 grams of something and 5 grams of something, so let's say I had 5 grams of one compound and I had 5 grams of another compound, and I reacted them, I should end up with 10 grams of a compound. All right? It should be conserved. When you do an experiment, you have systems and you have processes. All right? The system is what actually is going on. So say if I have a cup, and let's say I'm heating it up. Here's my flame. All right? And there's my Bunsen. Let's say here's a Bunsen burner down here, hanging out doing this deal. All right? And here's my flame. I'm heating up some water. All right? The system is all this stuff. The flame, the beaker, all that stuff. The process is heating, but the outside forces would be like wind, temperature, everything that could affect it. But this system, you have to recognize this system, there are parts to it and there are not parts. Things that matter, that directly and things that don't matter. So the system would be the glass and the water and all that stuff. And then the other part would be the flame. All right. So hopefully this helps out a little bit. We'll give you another video here in a little bit.